Hello, beautiful people, and welcome. In this video, we are solving exponential equations using logarithms. Now, we have solved exponential equations before using the same base property, but now we're going to be using logarithms. As always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way I may learn from it. All right, let's go ahead and do the previous example before I jump into these steps here. You can, start reading them if you wish. So then previously what we've done is whenever we have an equation, we isolate this here. The exponential expression is what this is called, but we just isolate this here, and then we use the same base formula or one-to-one property. I like the one-to-one rule. That's usually what I say. Here we're going to rewrite 25 in terms of the same base because we want the bases to be the same. So 5 squared is 25. Now that we have the same bases, we get to set the bases equal to each other and solve. So therefore, n is equal to 8. Now, this here, let me scooch this forward, is what we are going to be doing. So a little bit more complicated. The reason we have to use logarithms in examples like this is because we are unable to use the same base property. What that means is it's not pretty. It's not going to be a pretty 25, a pretty 36. It's going to be icky. And so we're going to use logarithms. Let's talk about our steps. Step number 1 is isolate the exponential expression. So we want the b of x by itself. If it's attached to anything, in this case 10, we want to get rid of it. Take log base b of both sides. So remember in integrated math 1 and pre-algebra, what you do to one side, you always have to do to the other. So what you're doing is you're going to take log base b of both sides. The base of the log and the base of the exponent have to match. So if originally I had b to the x power, I'm going to take log base b for the b's to match up. And if you recall, that's one of our identities, which ends up being just x equal to. Expand the log if needed using the power property. Sometimes you might have to do that. You're going to then solve and check for extraneous solutions. You may potentially need to use the change of base formula if your base is not originally 10. Let's jump in. Step number 1 is isolate the exponential expression. So basically the base and the exponent, highlight them, box them, put them in a bubble. It doesn't matter. I'm going to choose to highlight this. Anything outside of this bubble needs to be removed. I have a 10 that's being multiplied. I'm going to divide by 10. I'm left over with 5 to the 3k minus 3 power, and that's equal to 4. Step number 2 is take log base b of both sides. So what does it mean by same base? So I have a b to the x. This is my b to the x. What I'm going to do is I'm going to take log of both sides. I'm going to write log base b, and then I'm going to take log base b on both sides. Now, what is my log base b? We can actually just put number here, whatever this number may be. So if I'm looking, if this is my b to the x power, what I'm going to do is I'm going to take log base 5 of both sides. So what I have is log base 5 of 5 to the 3k minus 3 power equal to log base 5 of 4. Now that we have here, expand log if needed using the power property. Now, you may choose to use the power property first. I can do this in one step, but I'll explain why we can do this in one step. Using the power property, let's go ahead and bring this forward. So you have 3k minus 3 times, let's put that in a bubble, a log base 5 of 5 equal to log base 5 of 4. Log base 5 of 5, why we need to use the base of 5 here is because this equals to 1. This is an identity. So what we really have now is 3k minus 3 times 1 is equal to log base 5 of 4. Well, this is just equal to 3k minus 3 equal to, this is minus, log base 5 of 4. So now we are on step number what step number are we on? Oh, we are expanding the log. Now we are solving and checking for extraneous solutions. So how do we solve this? Always use the, you can use the, what are we doing? Change of base formula. You can also revert back to here, to exponential, if that helps you solve it. So let me write out the golden ratio. It's not golden ratio, what am I calling it? Golden rule. So b to the x is equal to a. Here's my double-sided arrow. And I have log base b of x equal to a. B of a, I got that confused, equal to x. Let me wipe that out. These should be switched as they are inverses. A and x. All right, let's see how to solve this. So I have a base of 5, and that doesn't help me anyway because I'm going forward, then I'm going backward. So let's see, we need to figure something out here. I am assuming at this point we're going to use the change of base formula. So 3k minus 3 is equal to log base 4 divided by log base 5. And then, so here, I hope everyone can see that I'm using the change of base formula, because if I use the golden rule, then the golden rule here is basically going to get me where I came from, and that's not where I need to go. So once I'm here, let's isolate the 3k. I'm a little bit running out of room, but hopefully I can make it. 3k minus 3 is equal to log of 4 divided by log of 5. I'm going to add 3 to both sides, and I basically am going to do this and get k by itself. Notice I'm not using a calculator just yet because I want to get the most exact answer, and I'm going to divide by 3, which is the same thing as multiplying by 1/3. All right, now I'm going to use my calculator. And what do I have? I have 1/3, or divided by 3. So in my parentheses, I'm going to do log of 4 divided by log of 5 in my parentheses. That's plus 3, and that's going to be divided by 3. So my answer, my k value, is about 1.287. You can do 1.29. Checking your answer here, I went onto another sheet of paper. Because we rounded, it may potentially be a little bit off, but it should be close enough to know that this is pretty much 40. So I'm going to go 10 times 5 to the 3 times 1 point. I'm going to do 287 just to give me a little bit more of an exact, and this is potentially equal to 40. We're not sure if it equals to 40. So for my exponent, I have 3 times 1.287 minus 3. That is 5 raised to that power, which is 0.861 times 10, and that gives me 39.9, which is about 40. That's pretty close enough to 40 to say that, yes, this works. Let's moving on to example number 2. Same thing. You're taking, oh, be careful here. A lot of things are happening. So your base is 4. It's not -4. Your base is 4. Your exponent is x plus 1. However, you have two things. We've talked about this before. You have a 7 and you have a minus that are not attached to the base and the exponent. So be careful. So step number 1 is get the base and the exponent by itself. So I'm going to first subtract 7. So I have a negative 4x plus 1. And here I have 11. So now I have 4 to the x plus 1 power, which is equal to negative 11. So what I did is I switched the sign, or you can say multiplied by -1 both sides, or divided by -1 both sides. Here we have to take the log of both sides. So recall, here's your b. Here's your b to the x. So you're taking log, and this number here has to be your base, and you're doing that to both sides, log base 4. So log base 4 of 4 to the x plus 1 power equals to log base 4 of negative 11. Now, you can stop there. You can absolutely stop here because of this section right here. This is you taking log of a negative number. Cannot happen. So immediately you can stop and say there's no solution. Let's continue. Let's do one more example. Okay, this one has a lot happening. Here's my base, here's my exponent. I have an 8, I have a minus, and I have a negative 3 that I need to get rid of. I'm going to start by adding 3 to both sides. So I have 216. 8 minus 11 to the 7k power. I'm going to subtract 8 both sides. I have a negative 11 to the 7th k power. This is 208. Again, switching sides. And potentially this one also could have no solution. So if we do log base 11, yeah, this one also has no solution. We have log base 11. Again, we're taking a log of a negative number. So this is log of a negative, meaning no solution. All right, beautiful people, that is it for this video. I hope you enjoyed it. Make sure you go through those steps and do lots and lots of practice, and I will see you in my next video. Bye!